Hello everyone. Have you been following along the recent trend of wipe coding and letting agents create software for you? And have you maybe wondering what is possible with wipe coding even today in the context of graph and diagram visualization? My name is Sebastian, I'm the CTO of yWorks. We are the diagramming experts, and today I would like to show you what we have been doing in the recent weeks, how we were using the power of wipe coding to do graph visualizations and diagram visualizations. I will show you some of the experiments that we did recently. So what's specifically on the agenda? What is it that I'm going to show you today? And so we'll be looking at agentic coding examples, meaning what LLMs wrote code for us in the context of graph visualizations. I would like to tell you what worked for us and what didn't work so well, and I'm going to show you what tools we used for this. Specifically, we'll be talking about these so-called MCP servers, more on that later. We'll be talking about skills and CLI tools that we provide to you, so that in the end, you will be able to try this out at home with your own data within literally hours. Also, please use the chat to ask the questions. My colleagues are there, and there will be a Q&A session at the end of this, so maybe I'll also be answering some of those questions in there. So what is not on the agenda specifically today? So we're not going to give you an introduction to yFiles and all the glory details. So this is not super developer extensive. And we're also not going to do an in-depth comparison or even a ranking or giving out recommendations on what models, what LLMs you're going to use or you should be using, what agents or harnesses, and what inference providers and tools. So this is all going to be outdated anyway in a few weeks from now. So take this as an example of what we used. And I'm also not going to give you any prompt tricks, some snake oiling in there, so you came to the wrong place for this one. There's a lot of this on the internet, so be sure to check this out if you're interested in this. We're also not discussing whether the programming task as such has been solved and other ethical or moral aspects of AI, I'm sorry to say. So, we're not going to tell you how to get new subscriptions or where to get your tokens from, but obviously we used some of these tools, and I would like to show you which ones of these tools we used for today's examples. Specifically, first let's go through the models that we used, and in no particular order. In this case, the order is going from smallest to largest. One thing that we used is Ornith, a 9 billion parameter model, a very small model that you can even run locally, and in my case, on a 6-year-old gaming GPU with 8 GB of video RAM. That's as low as we'll be going today, and you'll be surprised to see what works in there. But getting slightly larger, we also used 35 billion parameters, which is around like a 20 gigabytes download, just to give you an idea how much data is in those models. And this was run on a local Mac Studio, so this is still local. But of course, we will also be looking at some hosted models like open source models, GLM, DeepSeek, and then of course it's the big three with the one from Google, OpenAI, and Claude. And it's not always going to be these most expensive frontiers models that everyone is raging about, but I'll show you that even with the cheaper models, you can get quite good results. But again, this is not a recommendation. Just take this with a grain of salt, and it will be outdated in a month anyway. So if you run an LLM and you want to do some agentic coding, you need a so-called harness. And if you're not familiar with that, that's basically the harness is the environment in which an LLM performs or executes its actions, where it performs the actual coding. Typically, these harnesses run on your local machine. And you probably heard of the most famous ones like Claude Code, but we also will be looking at smaller ones like open source solutions, like one is Pi.dev, one is Open Code, one is Klein running in Visual Studio, and then of course Claude Code. We'll be not going into details because most of what we'll be looking at is valid for all of these models. We also tried things like Codex and Kilocode and Hermes and whatnot, but these don't have an appearance in today's examples as far as I I'm aware of. So we'll see them in examples later. So let's take a look at some of these experiments that we did. So if you haven't seen an agent in action before, this above here is a Claude Code harness running with a simple Claude Haiku model, which is the cheaper ones, answering a simple questions. So what we basically did is we took some example data, just raw connected data, and then we wrote a so-called prompt, laid back and watched the agent do the work for us. And we really did no manual coding here. So anything that you see today is not hand-coded, but written by the models in a harness. So the most important thing, and basically the only thing that's left to do for you if you do this, is after you've chosen the agent and the model, is writing a prompt, an initial prompt telling the agent what to do. And again, there's a lot of discussions out there how you should be writing the correct prompt. So don't take this as the ultimate source of truth. It's just to give you an example of what we did. It will be invalid again in a few minutes anyway. So, and also be aware that depending on the model that you're using, some kind of prompts or types of prompts work better or worse, specifically with different agents and different harnesses. So this is one of the examples prompts that we used. It basically tells the agent what kind of technology it should be using. It gives him a very brief introduction about the data that it's about to visualize. And then we'll tell it basically that the core instruction is to build a visualization from scratch using only something and then the technological stack. This will be different in the upcoming examples. It's not always going to be about yFiles. And specifically in these examples, we told it that this is going to be a proof of concept quality because we don't yet trust it to build production-ready code, and you'll see later on why, but it's great to do POCs. And let's dive into this. So this is an example that uses a very simple, small, local open source model. It's using py.dev, and we specifically asked it not to use yFiles or even any library at all. So all the code it wrote is code that is self-contained. The whole application is basically self-contained. It's a web application, and we gave it a data set and to calculate something. And because this is a local model running on our trusted Mac Studio, it came up at $0 cost in the end, basically, plus some electricity cost. But this all produced like almost 900 lines of code. And it took just 7.5 minutes, so there was some speed up in the video. And this looks really impressive at first sight. And the values, the cost is actually, well, hard to beat, I'd say. But if you look more closely at the result, you'll see something that is quite familiar if you've seen wipe-coded applications before. At the surface, they look really nice. So it's really something that's really good. And in this case, it's also good because the agent was able to build from scratch, meaning it understood all of the code that it wrote and all the implications that writing the code it had. So this, it was easy for the model to actually create in this case, SVG graphics. But if you look more closely, from a visualization point of view, it's actually not so helpful. Apart from some bugs in the interaction, it also has some like overlapping edges and nodes, and actually the edges go behind the nodes and you don't really see them anymore. So even if it looks nice, it's not really helpful. And worse, there's actually some misleading animations in there. So if you saw those animated items flowing through the graph, they actually don't relate to the graph data. So they give you a false sense of the reality. So you shouldn't be like basing any strong decisions on this. So, but either way, I thought it was quite nice to see that this is actually working on a local model. So what happens when you ask it to use a library? In this case, we asked it to use D3, which is a graphics rendering library. Rendering graphs is hard itself, and it contains a lot of graphic stuff. And so there's many libraries out there that help with the difficult part of actually rendering graphs. And so rendering rendering D3 is something that models typically will suggest, because there's lots, it's an old library and there's lots of code outside on the internet and in the training data. And so the models are quite confident at using D3. At first impression is actually that it's actually worse, in my humble opinion, than the no library version. That's probably because, well, the model doesn't have full control over what actually happens anymore, because it's using a library. It has to like recall the functionality of the library. So a simple, small model like this one tends to struggle. And also, if you look at the visualization, it basically has the same problems as before. You can't really see the connections in there. They are all routed behind those nodes, and there's even like labels floating around in mid-air, and there's actually no interaction. You can't even scroll or pan, because, well, it's something you have to like hand code in D3 unless you're using extra plugins. So D3 is maybe not the right choice here. So again, this was super cheap and super quick to do. It's actually quite a bit faster than the previous result, probably because it was able to reuse some of the library code. But as I said, I don't really think that is a convincing graph visualization in this case. So what if I tell it to use something that is more specific to the topic of graph visualization? And I specifically asked the LLM here to not use D3.js and also not yFiles, but choose a library on its own for the task. And in this case, it came out and used Cytoscape.js, which is a graph drawing, simple graph drawing visualization library. And again, at first look, it's quite okay, maybe not really pleasing, but the data seems to be there at least. The layout is also quite okayish, but if you look closer, it probably wouldn't work for a more complex graph, as the edges actually go behind other nodes, and so they are still ambiguous. Funny thing is that the interaction is actually a bit awkward. The zooming and panning is not really nice, and there's no overview, even though it's using a library which could provide all this functionality in theory. It didn't. And so I think this is quite telling that it's a problem for a model using a library, even if it's a capable library. And interestingly, it added this editing functionality in there, which basically helps with the ambiguity that you get by the overlapping edges in here. So again, it's a quite okay result in my opinion, but I wouldn't put this to production because of the ambiguity you get in there. It also probably doesn't scale very well. And also it did add some interactivity in here, which is really nice. And this is a frontier model. Remember that this is now a frontier model, not a local model. So this is a really capable model. And it did cost us some money, in this case 75 cents. And it was quite quick because it was using an inference provider. So that's actually quite okay. But if you look at the interactivity, there's no animations, no transitions in between. So it's for the money being invested, I'd say you can do better. So, but how? Because obviously agents or models have problems working with complex libraries and libraries that are powerful and can provide you with all these features and the great user experience. How do you do it? We try to teach those libraries, and I think in a minute you'll see that we were actually quite successful. So what we did is we provided them with tools so that they don't have to rely on their memory, on their training data when they're using more complex APIs. So the first thing that we did is we added so-called skills. Skills is a concept that you will find in many of the different harnesses, and basically any one of these, which is called modern, supports skills. Skills is basically a way to add more information to a model's context, which is basically its current working set of information that it's working on. And unfortunately, with larger libraries like yFiles, you can't put all the information, all the documentation in the context because context is limited. And even the largest models, and with free tokens, if you got these, you wouldn't be able to load all this information into the context. So what skills do is basically they concentrate on certain different aspects of a typical task, and the model incrementally requests this information to add this to its context, to learn about the features and to use this for the task at hand. So in the case of yFiles, these were the skills that we specifically added. One skill is teaching the LLM or the agent how to transform arbitrary data, that is connected data, into a graph, into the graph model in memory for display. Another one is choosing the right layout and configuring it so that you highlight the various aspects or the specific aspects that the user requires for their data. So this will actually tell the model how to identify different aspects or of the data, and then make recommendations with regard to what layout algorithm it should be using to arrange the elements on the screen. But it's not only about the arrangement, it's also about styling the information, getting the information from the data onto the screen. So choosing the right visuals and adding the right information right on the screen. So there's a skill specifically made for styling elements and even for implementing a custom visualization if that is helpful for the task. There's also a large range of different interactivity-related skills that tell it how to add things like tooltips or context menus where you can interact with visualization, and also on how to enrich the application, for example, to show detailed information about selected elements in the application, adding an overview, and so on. But it's not only about those like recipes, it's also enabling the agent to learn more on its own by querying the information that is available in a more active way. Specifically, there's this concept called Model Context Protocol, and those are tools which allow the model to interact with the outside world. And one thing that we did is we allowed the model to talk to our documentation, to query the documentation, basically the same way that a developer, a human developer, works with our documentation. As soon as they find an API, they look up the definition for that API, read the examples, and then from there on build the application. And that's what we did with so-called MCP tools. Again, all of these harnesses support this feature. And right now we have 8 different tools that are mostly centered around searching and looking up API members efficiently in the documentation without having the model to resort to grabbing the documentation file, which is very inefficient and burns a lot of tokens. Also, we gave it access to our developer's guide documentation and even the demos. And there's other tools that will help the agent to install the yFiles library and do some of the infrastructure. All of these come together in a yFiles CLI tool that we also built. That is a node script that you can execute using npx, and that helps with all aspects around building an application, starting from things like managing the library, or even just like signing up with us and downloading the evaluation version of the library, downloading the demos, the documentation, installing the MCP tools and the skills. And since this is a tool that runs on the command line, this is actually something that an agent can do itself. So you can instruct the agent to use the command line interface and then perform the various steps for you. More on that later. I have a full example for you. This actually enables the agent to work with it and to perform these steps for you, choose the demo, download, and install the skills, and modify itself dynamically. So now, with all this installed, we went as low as we can get, and I took my old rusty GeForce 3070 6-year-old GPU and installed Llama CPP, which is an inference engine, and a 9 billion model, open source model called Ornith, which involved like a 5 gigabytes download, and it basically has no knowledge about yFiles. So if you ask it, all the world knowledge it has is stored in 5 gigabytes of data, and it has an idea about how a graph visualization library could look like, but it doesn't know any of the facts. But now, with the help of the skills and the tools installed, even a local model like this on an old hardware was able to come to results. And this, of course, again, at $0 costs. It created a program with 560 lines of code. It took a while, it took 40 minutes because, well, my hardware isn't that good. But it managed to actually create something useful. It's a very, very basic application. But I asked it to come up with a custom styling. So this is not a style that we provide out of the box. I asked it to provide something colorful, shiny, and I think colorful resulted in it adding this painter's palette in there. But other than that, it doesn't even add the labels in there, which makes the diagram rather useless. And well, some would say it's some questionable design choices in there. But I was excited to see it being able to, obviously, only using the tools to actually come up with working code. Here's a more complicated data set that I also sent to the same model. It's a company organization chart. And I asked it to come up with a custom visualization for the node, and it's pretty broken. The problem is this is all a one-shot. So I told it to create a visualization, and it went on, wrote the code, and I executed it. So this model has no vision capabilities. It didn't check the output and see that there's actually obviously an offset that it included in all the visuals. So the model, this very simple model, has very poor spatial thinking basically, and it was slightly off. I guess with the second prompt I should have been able to fix it, but this is just for you to see that it's not always working. It took just $0 and the end result was just 400 lines of code, but it took more than 2 hours because the model took many detours and made a lot of mistakes. And I think what was the problem here was basically that with those local models, the problem oftentimes is the amount of context that they can work on. And specifically here, I think it failed managing the context, and while it was working, it restarted many times again. So probably too many steps at once for a small model like this. But this is, if you compare this with a handwritten demo that we have on this very same data, I mean, obviously, there's still a lot of work to do for this model to come up with something really good. But, well, it's the smallest and worst model that I tried. So how is it going to look like with better models? This is a slightly better one. So this is a 35 billion version, like 20 gigabytes of download, still running locally. And I asked it to start from an empty demo that I provided it with. So there was no graph visualization in there. And then we did multiple smaller steps. For each of the conceptual steps of the creation of the application, we did a separate prompt. And this actually turned out to work pretty well when you keep the context limited. So we started with a prompt like this. Here's the workspace. Use the yFiles configure layout to come up with a layout, and it actually identified the structure correctly and applied the layout. So this is incrementally working on existing code. So it first had to understand the code that I gave it, understand the data, use the skill, and then apply the right configuration. As a second step, we asked it to add some styling to the nodes, and well, it did come up with a styling. Again, it's not that perfect, but it's nice for a small model. It understood the API, and again, with a second prompt, or maybe with some feedback loop where I can pass it in the resulting image, it would have been able to improve upon this one. The same with interactivity. So we asked it to add some HTML tooltips to the nodes to show the information, and that actually worked super nice. And same thing for context menu. So if you right-click on an element, you want to see an action, and we ask it to implement that action for us. And so in this case, it was just a simple zoom to node action, and that actually also worked flawlessly. And last but not least, no, it's not last, second last step is added some interactivity, which is really easy for the model because it's basically just writing HTML, plain HTML file, and just the glue code to the yFiles selection. And that's pretty easy, a pretty easy task for the model. It came up with a flawless implementation of the details view. Last but not least, now it's last, we asked it to improve upon the layout because that's really a very wide layout in there. And it doesn't know about the results. So we told it that it's a very wide layout and we would like to see something more compact. And we told it to use the tools that we provided to come up with a solution. And it did, and actually come up with a configuration that resulted in a much more compact layout. So that's actually a usable application, at least of proof of concept quality, I'd say. But can you really do one-shots of complex application? Let's see how the more capable models perform, the ones that are hosted. So this is a state-of-the-art. It's Claude Sonnet 5, released just, I don't know, 2 weeks ago, last week, I don't know. And this is running Claude code using yFiles. And just as an example, this first without MCP tools, without the MCP tools again, so no skills installed. And still, it was able to like infer the code. It doesn't know all the yFiles details. It had to do some round trips, and quite a lot of them actually. So it used grabbing to actually read through the API docs, which it found online or on the hard disk. It took a while, and it produced like 1,200 lines of code in the end, in the resulting application. But it's actually quite a nice application. It took half an hour to this, and that's why the cost is so high. So it burned a lot of tokens in there. I think I really like the application. It has good and unambiguous layout, really nice, smooth interactions. There's things like highlights in there. There's even like this animation slider. And something that the Anthropic models like to do is a super dark mode application, very dark with some highlights. But yeah, nothing that couldn't be improved with a change in prompt, I guess. But anyway, this was without the tools, $7.30, half an hour. But still, you get what happens when you do this with the MCP tools enabled. So that's the same model and the same harness. And now the cost went down to $2.45, and it was just like 165 lines of code that it eventually added because it found the right demo for the data, reused that demo, and adapted the data to the demo so that the demo works well with that data, and integrated it. So this obviously took just 10 minutes. And apart from the fact that it actually still contains the demo UI, which I would have told it to remove that to better match my corporate identity. This is basically a perfect result because, well, it was able to use a perfect demo that we already have online, and it was able to find that demo on its own and reused the code. And so this, but it's with a different data set. So it didn't just like copy the demo blindly, but it adjusted the data to work for this specific use case. That's the online demo. You can try it out, the original one, if you want to compare it. So what if I tell it to not reuse an existing demo, but really start from scratch? So here's for a change. This is Gemini, the Google model, Gemini 3.5 Flash, working in open code with yFiles, and the tools and the skills enabled using the yFiles CLI, but working from scratch. And this one actually is rather cheap. It costs $6, and it produced 2,000 lines of code. And it basically, with one refinement step, we got a complete application within less than an hour. And that's really an impressive application in my humble opinion. It's with lots of interactivity in there with filtering, nice animations, custom node styling, custom tooltips, and even the heat map integrated, which was one of the features that we prompted in a refinement. So we get this, in this case, it's a pharmaceutical supply chain data that we added, and it created this very nice application. So some would say $6, that's a lot of tokens, but honestly, if even a yFiles expert would have implemented this application a year ago manually, it would have probably taken them like a day at this level of quality. And that's super clean code with quite nice, at least proof of concept quality. Still something that you shouldn't be just releasing blindly, but really high quality and specific to the data. So really nice results. Let's look at some more other results that we had. So this, yeah, got to point that out. So basically with this, giving it your own data, we were able to create a bespoke graph visualization of POC, really good POC quality in less than an hour, and this at the cost of, well, $6.50. That's really impressive. And one more example, totally different AI. This is OpenAI GPT 5.5, working with Klein right in Visual Studio Code, again with the MCP tools, the skills, the CLI, and asking it to create a BPMN visualization from scratch. Finally, not a dark mode application. That seems to be a tendency of OpenAI models. 13 minutes, 6 million tokens. I don't have the exact costs here, unfortunately, but it should be less than $5. Only 700 lines of code and just 12 minutes. And in 12 minutes, we got this application with custom styling for the different BPMN, following the different BPMN standards, and a complex layout with automatic layout with swim lanes, with pool nodes, and so on. Interactive with an overview. Really nice results in my example. So in this case, from the data to the diagram to the final running application, just 15 minutes. Imagine that one. So how can you try this out yourself? So even today, with these tools, is that possible? So we have this new nifty button on our homepage that you can try out, and this is how it works. Basically, what you have to decide is you choose the LLM. You choose your weapons. You choose the LLM, you choose the agent you want to use, the harness. You provided the data, and then you mix in yFiles with the MCP tools and the skills, and then you get the graph visualization. Basically, all you have to do is go to yfiles.com, go to the yFiles SDK, click on that prompt, and paste it into your agent. Then the agent will go on, let you sign up for yFiles. You just hit the accept button, and then it will download and install the skills and the tools, basically without you having to do anything. That's super nifty. After a restart, you have the skills and the MCP tools enabled, and then you can start asking it to create a program for you. Just pass it in the data and let it do its work. And in this case, after a few minutes, I think it's 2 minutes, I asked it to create a Hello World application, and this went from 0 to the final application within just a few minutes. So these are the steps again. yfiles.com, find the copy prompt button, paste it into your agents, and then point it at your data. And last but not least, please do share your results. I'm so eager to see what you were building with this. If you run into issues, and you probably will, because yFiles is huge, and even the AI with all the access to the tools might not find the answers to all of your questions, then please do turn to our human support. You can opt into quick AI questions to get answers more quickly than we can provide them to you within seconds or minutes. And you get this if you're during the evaluation, or if you're a customer with a subscription, you get our answers even if your AI gets stuck. So please do connect with us. We're always happy to help and provide you with some ideas on how you can improve your visualizations. So I hope you've seen what's possible today and you got an idea. And I'm really eager to see what you will build with that. So please send us feedback and send us examples of what you built. It has never been easier to get started, so do it today. And if you're running into problems, let us know. My colleagues from the consultancy team will be more than happy to help you or even to consult you with ideas on how to create that perfect prompt, or to create a specification for your agent to create something awesome. Well, that's it from my side. Hope to see you soon, and happy pipe diagramming.